Hello, and welcome to CHEE Chat, the chess podcast where we talk with our professors to learn more about them and the chemical engineering field in general. I'm your host, Gregory Brock, the VP Academic of Chess. Today, on episode 3, we will be talking with Professor Leask. Today, we have Professor Leask, if you wouldn't mind just introducing yourself quickly.
Hi, I'm Professor Leask. I am in the Department of Chemical Engineering, and I'm one of the associate chairs of the department.
Mm-hmm. So definitely, I guess we'll just sort of begin with maybe the more basic questions. But I just wanted to sort of ask, I was curious to see sort of the ways that you've adapted to teaching in these pandemic circumstances.
Okay, it was challenging to do. The last term was teaching basically the stats course, data analysis and design of experiments. Given that I've always had a tablet and penable technology, for me it wasn't too bad. I could continue to use my tablet to write notes in real time, which I think is a part of the learning process, is for people to write their own notes. It's better for the students to sort of write down their version of what I put up. It paces the lectures better than having PowerPoint slides just flash in your face. Students tend to tune out.
Oh, something I could just say from my perspective is that that's something that we've constantly been giving feedback to for profs as well, is that when things go too quickly, like we can't process it. So the act of writing stuff out really helps us a lot. And I will say, actually, for U1s, they really, really appreciated that from the data analysis class.
Yeah. I think there are ways to do it to mimic better a lecture environment. The low hanging fruit was just to throw PowerPoint slides up and talk to a screen. I don't think that's the best way for people to learn. So for myself, it took some adjustment. Talking to a bunch of black squares with names in it is not easy. It's much easier in person to be able to gauge if there's been something that's missed, or I'm going too fast or too slow. But by the end of the term, it was a little bit more interactive, and I think the lectures were more useful.
Yeah, and again, just something I want to mention is that even though obviously like it can seem sort of depersonalized, there's black squares and everything, students really responded very positively to what you were doing. I can just say this from like the academic forum that we've already done, but they did respond quite positively to what you're doing. So I think that that's just one of those things where it might be harder to get that reinforcement in the moment, but it was a very positive experience overall. But actually sort of, I guess, congruent to that, I was curious about, not just for you personally, but on a more macro scale, how do you see that the way that we've had to teach this semester, even when we're in an environment where we're going to be in person or other things like that, how do you feel that the way that we've taught this semester might change the way that universities will operate in the future?
I don't think anytime soon we're going to get back to full lectures with full classes. And I think that's just going to be a reality for some time to come, where there will be some in-person, and the university's already announced that there will be in-person. But that's more likely to be for labs in small groups, some tutorial sessions, some lectures, but definitely assessment. So tests and exams. And I really think that's where the pandemic has shone a light on the limitations of doing things online. For instance, you just said you had a 36-hour exam. That's a take-home exam. Take-home exams can be good ways of doing things, but they're also very prone to being done in a group, or having people disadvantaged because they don't have the same resources available as other students. So I think the leveling the playing field again, and having people do stuff in class assessment is really going to be the next step to getting back to normality.
Yeah, I definitely agree with that. That's something where, and after this, we can move on more directly to the questions
Yeah.
about you and your research.
Yeah, no, that's
But
fine.
just a sort of a last statement on that, that's something I agree on as well. It's been a major source of concern for us where now even in the past, having access and having connections with like upper year students allows for you to better prepare for courses. But now it really feels like the sort of paradigm has shifted necessarily away from doing a lot of studying to get it to, oh, do you have like a good group? Oh, do you have like how can you, it just feels like it inherently disadvantages
Mhm.
maybe groups of people who don't have solid Wi-Fi or are in different parts of the world or other things like that. And that has been actually a huge equity concern on the VP academic end as well.
Yeah, I agree. I think there is a reason universities exist, and people have never put as much stock in something like an Athabasca University or a University of Arizona that's 100%
Hmm.
online.
Hmm.
You get what you get.
Exactly. But I guess to move on to
Yeah,
hopefully more
no
positive
problem.
things. Hopefully more positive things.
Yeah.
I was just curious to see. So obviously this is a very open-ended question. Answer it how you'd like. But I was curious to see what your sort of experience, like in undergraduate, was like. So where did you study? Why did you
Yeah.
ultimately end up choosing chemical engineering? Like, what was that sort of like for you?
I was all over the map. So see, one of your questions was, did I have good grades? So through high school, it wasn't until the end of high school, and at that point, I was in Ontario, and we went to grade 13.
Yeah.
So grade 12 and 13, I did well. I didn't do that well, but what I did do was I wrote the Descartes math competition, and
Hmm.
I did very well on that, and that got me into the University of Waterloo with a scholarship
Yeah.
into mechanical engineering. So I
Hmm.
actually did my undergrad in mechanical engineering.
Yes, we actually have that was a mistake on my part. There was
Yeah,
a
no problem.
misunderstanding.
And so again, it was near the end of my undergraduate degree where I guess I peaked at the right
Mhm.
time and got my marks to a point that allowed me to get into graduate school at
Mhm.
University of Waterloo. And there I sort of shifted. I did it in mechanical engineering, but in collaboration with kinesiology,
Mhm.
moving towards more of the life science options.
Yeah.
Um, and that then led me to going to the University of Toronto for my PhD, again in mechanical and industrial engineering, but in at that time the Institute of Biomedical Engineering,
Mhm.
which is now its own department, but at that time uh, they didn't have a department there. Um,
Mhm.
and once you're in grad school, it's a different beast. It's more about your research. You have to do okay in your courses, but it's more
Yeah.
self-driven discovery in your own research.
So it's more about what you produce as opposed to the grades that you get in classes that you're taking
Right.
necessarily.
Yeah,
Yeah, it's
you need to pass things and you need to do
mhm.
core courses and that, but your success is measured on the number of publications, your impact
Yeah.
in the field that you're researching.
And what do you say of all of that? Like, what did you say that you found the most sort of interesting or engaging?
I early on in my undergrad, it was transport phenomena, fluid
Mhm.
dynamics, heat and mass. Well, it's funny, mechanical engineers don't do much mass transport.
Yeah.
We do lots and lots of heat transport. I had 3 courses on heat transport.
Mhm.
Uh, so those were the courses that interested me,
Mhm.
as well as some of the mechanics of materials, mechanics of machinery. Um, those courses were of interesting.
Mhm.
Um, the you know in general, there's always courses you don't like. Stats was one I didn't like,
But
but
I I
it
think that
became very important as I went on throughout my career.
but I often think that I almost wish that there was people who become obviously professors and other people who end up teaching. Um, I almost wish that they more taught so the courses that they didn't enjoy or that they struggled with, because I feel like that gives them insight into how to deal with it better.
Yeah, yeah, I would say that the data analysis, I call it stats because it is stat.
Mhm.
Um, you know, it is a dry course. It is very the there are some very cool things you can do with stats, but the theory itself is really not that
Mhm.
interesting. So, you know, I think a goal with any course like that is just to try to get people engaged and seeing not the theory, but how applying it can answer some questions that are of interest to them.
Yeah. So one thing as well that I'm curious about is that you talk about sort of going into obviously undergrad, and obviously you end up going through a whole PhD program and all of that. I
Mhm.
was curious to see, what was that always the plan, or was that something that sort of developed over the course of doing those studies?
Um, yeah, I don't know if there was a plan. Like even, you know, you've experienced this. You're at a young age, and it's like, oh, you have to sort of pick a career path.
Hmm.
And I was interested in engineering.
Yeah.
And I picked mechanical just because it was the one that sounded interesting to me at the time.
Yeah.
As you go through, you realize that there's only minor differences between most of the engineering disciplines. There are sort of subspecialties that chemical does versus mechanical. Maybe electrical is a little bit different, but I think I could have started in any engineering and ended up in a similar place to
Hmm.
where I am now.
Hmm.
I think as I went through at the end of my undergrad, it really became, oh God, what do I do now? You know, I had the advantage that I did co-op at the University of Waterloo, and
Yeah.
what I did find is I worked early on. I had some crazy jobs. My first work term was on a fishing trawler as a ship's engineer in
Hmm.
South Africa. That was eye opening. Then I did 2 work terms at Westinghouse in the steam turbine division at the plant in Hamilton. And that pretty much taught me I never wanted to do that again. Then my last couple were with the Defence Canada, the Defence and Civil Institute of Environmental Medicine in Downsview in Toronto.
Hmm.
There I got to do human experiments with divers, looking at rebreathing apparatuses for military divers. And that's really where I got interested in research.
Hmm.
And so I saw sort of that avenue melding life sciences in with the engineering is where I wanted to go. But then when I was graduating, there wasn't a job available. So I decided to make up my own research project with one of the professors in mechanical engineering. And that worked out well. So,
Yeah, definitely. Wait, can you actually? So I'm really curious about all of them because it's very
yeah,
interesting. But that fish,
yeah.
oh my
So,
God, the trawler
as
one, sorry.
yeah, so you can imagine being here it would be after your U1 year
Hmm.
with pretty much zero actual engineering experience. You've taken
Hmm.
the basic courses in that. I My marks were not fantastic, so I didn't get a job through the first round. I had to find my own job,
Hmm.
so I ended up using connections through my family to be able to go visit family in South Africa
Hmm.
and get a job on a fishing trawler at I&J Fisheries.
That's
So
really interesting. And what do you feel like with all of those? So you talk about sort of how I guess your experience in industry sort of informed what you wanted to do in academia.
yeah.
I guess in further words, as you sort of progressed in academia, what kept you there versus maybe sort of reappearing out in industry?
I Well, definitely not the money.
Yeah.
Let's be honest.
Yeah.
You don't go into academia
Hmm.
to chase the paycheck. Let's put it that
Yeah.
way. But it was more of the being my own boss and deciding what I wanted to research, what
Hmm.
interested me. being able to come up with the questions instead of having other people tell me which questions I'm supposed to be answering.
Mm-hmm.
So that really was the goal for me. And I've always loved teaching. From a young age, I was always involved in coaching, in mentoring, things like that. And so I wanted to be able to teach and do research. And the only real way to do that is through academia. So that's sort of how I set my goals.
And something I'm really curious about is just sort of, I guess, give us almost a brief overview of the questions that you're asking right now then. Sort of what's your current research that you're going into?
So I do a lot at the hospital. So part of my PhD was hospital based, and then I actually did a clinical fellowship at the Toronto General Hospital in pathology when I was done. So many of the questions that my research is based on is from my experience through the hospital. Right now, one of the big studies we have is looking to see if we can come up with better guidelines for surgical intervention of ascending aortic aneurysms. So these are aneurysms that form in the largest vessel just on the outflow tract of your heart. And the problem is as they get larger, they can rupture. And if your aorta ruptures, you're in big trouble. Right now, the only criteria they have is size. And you can imagine that the size of my aorta versus a 5'2" woman are going to be different just by on our general physiology. So it is a very poor predictor of what the risk is. And that size indicator really is a surrogate of a mechanical function. So we've been using imaging technology, ultrasound imaging, to try to find the material properties of the ascending aorta to give surgeons a better way of predicting the way that the risk of that aneurysm. Because the surgery involves basically cutting your chest open, stopping your heart, putting you on heart-lung bypass, cutting out a section of your aorta, and then putting in a prophylactic graft in that place. So it's very, very intense. And
very, very involved. But
so that's one of the projects that I have going on at the hospital. And there's that project has sort of spun off into surgical simulation using 3D printed phantoms to help train the surgeons. Right now, all of our surgeons, the primary training is on patients while a senior surgeon watches them. That's not the best way to learn a skill. You should come literally to the table with some competence before you start doing it on patients. So we've been doing that. And then there's some other imaging technologies. Once you get into a setting like that and being able to discuss with clinicians, knowing enough of the medical science that you can have an open discussion with them, you find there's all sorts of needs in a clinical setting for engineers, and the way we think about problems, the way we break problems down, come up with simple solutions that build up to a larger answer.
Well, that's very interesting for me because my mom is actually a family physician, so obviously a very, very different position. But I grew up around a lot of people who were involved in medicine, and also a lot of people in my family are engineers of just different sorts. So I think that's quite interesting just from the perspective of the people who come from that medical background have an entirely different way of thinking than sort of an engineer coming into that. So I guess what I'm curious about is, can you speak to that sort of experience of being the engineer in a room full of doctors or lab techs or other clinicians of that sort?
Well, it really comes down to exposure. I was lucky during my PhD to be in the hospital, and actually a couple of the doctors there, vascular surgeon, Dr. Johnson, and the head pathologist, Dr. Patani, sort of took me under their wing and treated me like a resident, allowed me access to things that normally engineers wouldn't get access to. And it's really exposure, realizing what they deal with every day.
Yeah.
There's lots and lots of people that do biomedical science out there, and they've never actually stepped foot in an operating room, never actually seen what their reality is and the decisions they have to make. Mm-hmm. So, you know, with my my grad students that are working on these problems, now we attend a clinic every other week with the doctors. We review every patient with them before they go in and do their interview. We discuss the case. We talk about the implications of it. So it's that exposure to being comfortable with each other and trusting each other's sort of specialty in our area of interest. So,
why is it that you feel having that sort of exposure with the patients and with the hospital setting? I want you to elaborate a little bit more. I think I understand what you're saying with that, but why is it that you feel that that improves your perspective as an engineer on those problems?
Well, because you really understand that what we think is a problem to them is not a problem, because that's really not going to come into their decision making in the end.
Yeah.
You know, that's theoretically, yes, that may be a problem that needs to be solved, but that's not going to help this patient today. So they want to know, they're very good at coming up with ways that are easy to understand, not only for them, but for them then to be able to convey to their patients. So one of the things we were doing early on, and we still do, is when there's a surgery, my students go to the operating room, they collect the tissue, and we take the tissue back and we do all the mechanical analysis on it, tensile testing. We do all the histopathology, looking at the cells, the composition and the degradation in the tissue. We do some of the molecular biology. We do the genetics on it. But in the end, the doctors have sort of taught us that you've got to come up with one or two simple metrics that gives them maybe a score on risk, but it's got to be simple and easy to explain, because A, if they don't understand it, they're not going to use it. And B, if they can't explain it to their patients, then it's of little good to them as well.
Yeah. It's like if it requires a fitted model and solvers, then.
Yeah. If we, as soon as we start talking, and that's one of the things we did early on, oh, well, we're going to use a Mooney-Rivlin hyperelastic model, and we'll get you these three constants. And they're like, great. No. What the hell does that mean? So we actually dumbed down the analysis to a point where it's almost first order analysis, very simple, easy to use, give it names like a stiffness index, easy to explain, and then it becomes of use to them.
Yeah.
So there may be lots and lots of heavy math and modeling behind it, but in the end, what they see and what it produces to them is something they can explain.
And do you think that your sort of enjoyment of teaching, your sort of enjoyment of those mentorship roles, do you think that that translated well into understanding how exactly to sort of, I guess, dumb it down, but I don't really necessarily even want to call it that, how to sort of simplify it into that more usable, better form?
Yeah, I think, part of it is I love to teach. I'm a people person. I'd rather see people in person. I'd rather sit down and talk.
Yeah.
I hate exchanging things through email and text. I usually just take call and talk to people. It takes sort of a give and take to feel people out, understand their perspective in order to be able to explain things well to them. So
yeah, definitely.
And it goes both ways, because the amount of learning that has come out of working with doctors in the clinic is immense for both myself and my graduate students.
And that was actually something that is sort of related to what I wanted to ask next. You talk about how you run all these different types of tests, from sort of biochemical, there's obviously the stress tests, which are more classical to what we would end up doing.
Yeah.
But where did you sort of learn that more, I guess, integrated or cross-disciplinary approach to it?
Yeah, well, so the mechanical analysis is applying an engineering tool to it. We're just using human tissue. So
Of course, yeah.
it evolves over the years that we've been doing the analysis. We use a biaxial tensile test to be more representative. So that is an engineering tool applied to it. The molecular biology and genetics are things that over the years I've evolved. My lab has evolved to that point. My lab started as a cell culture lab looking at forces on vascular cells. That's really what I set up my lab at McGill to do. And then I always had the clinical research on the side. So from that, most of the experience that my students had built up over the years and how to process, how to do the genetic analysis came from that. My experience in pathology taught me how to be able to do histopathology, look at cell structure, look at tissue structure, identify degradation, identify the different components, the inflammatory involvement. So, you adapt over the years. You have a research problem or question, and you end up becoming an expert in what you need to be able to answer those questions.
It's sort of like ad hoc expertise to answer the questions that you have coming to you.
Yeah. Now, we rely on a lot of core services. So our genetic analysis is at the hospital is done by the core geneticists there, and we get the reports and interpret them. In my lab, we use Genome Quebec to do the entire genome of our cells and give us the upregulation, downregulation, and then we learn to interpret it. So there are a lot of core services available that help researchers sort of get into that area and make sure that the data that they're collecting is done properly.
Yeah, and actually something as a more general question, obviously as someone who's been very successful in research, I was curious to see what are some advice that you might have for, say, like a student in McGill who wants to get involved with research?
Number one, find out what you're passionate in. The SURE program's gone, but we still have the EUL summer student program that is open to catch other students. We have 494, 495 projects that you can do during the term where you're in the lab doing research. There's a limit to the number of students every professor can take, but if you can convince somebody, right now I have, my last couple of students have come from bioengineering just because of the SURE program. That's the ones that get ranked. We don't get to choose. We put in a ranking and then it matches us up. But
yeah,
it gets you that opportunity to see what lab research is like, and you have to learn to adapt and do the best you can with the problems that you're given. So I would, anybody that's looking at research, I think they actively, and they should start looking in September, October.
Oh, of course, yeah.
Talking to people, because when the SURE announcements come out in December, it's you want to know what is going to be available before that.
What I found for me last year, actually, because I did it with Dorval last summer, Professor Dorval, I found that I talked to her at the beginning of the year, and I kept on checking in with her over the course of that. So by the time that we actually ended up getting to SURE, it was a done deal. It was already locked in. So I find that that's probably the best way for people to go about with SURE. But
I agree. But there are unfortunately it's only for Canadian students, but the EUL scholarship we used to run it before there was SURE, and that was how many of my grad students started. They did a summer project with me with the EUL, and there it was much more flexible because if there was a student I was interested in, I could commit to them right away because I knew that they were eligible for the UL scholarship, and then it was something we could do. With Assure, it's a little because now we don't even give the EULs out till the Sure are done, just so that we make sure that we maximize the number of students we can get in the department. But it's a little bit more difficult for us as professors to pick the students for the project. It's we can pick a project, we can put in a project, then we can interview a bunch of students and hope that it matches up.
Yeah, definitely. So I guess something as well that I'm sort of curious about is to go back into your experience of teaching at McGill. It's been about 18 years, right?
Yeah, that's scary.
I guess what sort of what do you feel like has been the thing that sort of kept you here, sort of kept you, I guess?
So, well, there's sort of two embedded questions there. Kept me in Montreal is my family.
Of course.
Family sets up roots, and we, my kids now, one is now in CEGEP, my other one is still in high school. The thought of uprooting them and moving somewhere else and having them start up again is
no, not really.
That's a lot of entropy to get over. But McGill as well, I think we have a fantastic department. I do a lot of service work for the university, and there are some very dysfunctional departments in any university. That goes to say, but our department works extremely well.
I wanted to say that I don't want to, again, of course, not naming any names. But I do know what you're talking about, even from the student side.
Yeah, and it goes from our technical staff, our support staff, through the professoriate. Everybody participates, and people do it not because it's their job, but they want to help you. And I think that is definitely not the case in many departments. They'll come up, union says, that's not my job, I'm not doing it.
Yeah. So, and that's actually something I wanted to comment on just as a side note is I know I'm not the first one to come up with an idea, something like this, but what I do know is that this is like the department where this has by far been the most successful in terms of getting profs. In fact, I sent something out to the professors, and then within a day, I had I think 7 or 8 profs immediately respond, I would love to do this.
No, that's great. I'm sorry, I was a little later.
Oh, no, don't worry about it. Don't worry about it at all. But that's what I mean is it's just there's a lot of enthusiasm on the prof side as well, just coming with with interest for helping out with the students.
Yeah, what in our department, the philosophy has always been that when we interview people, if they can't teach, we don't care if they're a superstar. We're not going to hire them. Yeah. Whereas many other departments in this university go, it's okay if they can't teach. They're going to bring in the research dollars and they're going to be a superstar. And we've always felt that our mission here and our biggest impact is in producing good quality students to the world. It's never going to be our research. I would probably strike me down with lightning if this ever happens, but I don't think we're going to have a Nobel Prize out of ChemEng. It's I'd love to win one, but our mandate is to educate and to produce good engineers and researchers.
But we do have a Moderna founder, so.
Yes, we do. And he also, his nephew came through our department as well. There are some, and I think part of the reason that he was so successful is he got a very good quality education. He also went on to do, I think it was neurology afterwards. Once he was done chemical engineering, he has always been an achiever, and we get many students like that. There's many. The reason we have the EUL scholarship was another one. Lamoth was a undergrad in our department that eventually went on to the University of Minnesota and business and made his money afterwards. But there are a lot of very, very good, talented people that have gone through our program.
Definitely. So one other thing I did want to mention is that you talked about how there's a general applicability in between the engineering, but based off of your experience in teaching, and obviously I know that you've also taught courses with bioengineering, correct?
I've helped with project courses. I've taught different classes in different departments.
Yeah.
Bioengineering, biomedical engineering, experimental surgery, other departments like that. Yeah.
But based off of that sort of experience, you say that there's many things in common, but what do you feel like are sort of the similarities and the significant differences between, I guess for you, it's mostly mechanical engineering, and then also you have the most experience with chemical engineering as well. But what do you feel are those similarities and then significant differences?
Well, the advantage of being in chemical engineering when I started here was good laboratory skills, which you don't get necessarily in other engineering departments. You know, their laboratories are, let's go do a tensile test. It's not, do a serial dilution, make me a stock media of this. You know, these are things that chemical engineers can do. And yeah, it takes some training, but it is some basic skills in the lab, how to set up things in the lab that really were an advantage when I was setting up my lab. Right now, some of the things that in chemical engineering we don't do as much of that something like a mechanical engineer would do is solid modeling, coming up with 3D designs and drawings. It's not something that chemical engineers can't do, and most of my students learn how to do it on their own, but it's not taught as part of our core curriculum. In general, you know, when I first got to this department, I'd never heard of fugacity. There's a whole area of thermodynamics that no other engineer deals with.
Trust us, no one going through a chemical engineering past U0 can forget fugacity. So
yeah, exactly. So there, you know, these looking at the thermal properties of materials, those are things that other engineers don't do. They don't look at the micro scale as much, unless it is purely on the material composition side. So it is again another aspect of chemical engineering that gives you insight into how things work together a little bit better. As I said, the mass transport, most other engineering disciplines don't really deal with mass transport. They either you get taught fluid or heat transport, and well, you can figure out mass because it's the same thing but different equations, sort of thing. So
yeah, definitely. Yeah. So I'm not going to take up your time a little bit, like too much more. So I just have a couple more questions that I'm actually interested in asking.
Yeah.
So I guess sort of as a general overview, what do you feel are some of the most prominent milestones that your lab has achieved, and what are sort of the future ones that you want to sort of strive for?
So early on was developing three-dimensional cell culture models for looking at vascular biology. That is a sort of a technique and a method that we've used to look at different drug interactions with cells over the years. That's been successful, and methods now that are used by other labs around the world. So that was good. On the sustainability side, working with Professor March and Dean Nicell for years, we've been looking at making sustainable additives for plastics, and now looking at totally sustainable plastics. My early involvement was on the biodegradation side, but you know, as it's evolved, more of the material science and some of the compositional work I do. That's been very, very successful. We brought a couple of these additives to industry. One right now is going through is being patented. And now we've sort of moved beyond just additives to entire plastic formulations.
Mm-hmm.
And then on the clinical side, work with the surgeons and cardiologists on thoracic aortic aneurysms and giving them other tools, surgical decision-making tools, to make better decisions on which patients should go for surgery. It's been good. I've had many residents that have come through my lab as well because they get a year to do research and have gone on to different places and sort of have continued on that research topic. So I think that those three are the three main areas that I feel my lab has made an impact.
Yeah, definitely. And I guess even for you as a professor or just sort of you on your own, what are your sort of dreams or what's like your big thing or ambition for the future? Like, is there anything that you feel like is sort of the next step for you or your lab?
Really, we're getting very well integrated into the clinic and the new MUHC. So continuing on doing that, because I think it's fundamental to sort of the next generation of biomedical engineers to be people that actually understand what goes on in the clinic, are comfortable in it. You know, it's not easy to go see somebody's chest being opened up and then being put on heart-lung bypass. It takes some time to get used to, but then being able to feel like they're making an impact on how patients are treated. And you know, when you actually start to see these patients and they're no longer just a name, they're an actual person, it really does give you an amazing sense that, okay, what I'm doing is worthwhile. It is having an impact on somebody's life.
Yeah. And one thing I will say that I think is really interesting and I actually really appreciate from the way that you sort of talk about your past and your sort of future expectations is that you mention a lot and you put a lot of emphasis on the people who work with you and like the students who come in and help you. And I think that's really nice to focus on also the student and the human aspect as opposed to just sort of like the ideas or the research, because oftentimes it can seem very abstract in a way.
Yeah, well, in reality, there are very, very few professors that actually do any of the work. You get to a point, and it's just the way our system is set up. My job is to set the research direction, find the funding, manage the students, manage the resources, help write the papers, and get them published. 99% of the actual work is done by the students in the lab. They are the ones that are going to get the tissue. They're the ones that are in the lab pressing bars for our materials or developing the cell culture models and analyzing them. It's always telling when I go to my lab and I'm looking for something and I have to ask where it is, because it is my lab, but I'm not in there every day doing things in it.
But it's a thing that you've built up, but maybe you aren't there for the day to day.
Yeah. I buy the equipment. I have set things up in there, but I am not the one that's there day to day. If you've done a summer project, you know that. I know with a young professor, they tend to be in the lab more often, but that is very limiting. And you get to a point where you can't do that every day and teach and do service and write grants and papers.
24 hours in the day.
Yeah. Yeah.
So on that note, I would love to talk to you for longer. I think this is really interesting. I think that everything we've been talking about is really amazing, but I won't keep you up for too long.
Yeah,
so
no problems.
That's all the time that
it's been a pleasure. I really hope we get to do this in person. We used to have frequent, I don't want to say pub nights, but there would be events where we get together with the students and we'd be able to sit down in a open environment and just talk. And I think that's something that there's a whole class of students I've only met virtually, and there's a whole class of students that are about to graduate that really it's going to be a little bit of a letdown. It's a shame that we don't get to bond with them like we usually do.
Yeah, I think that's one of the biggest struggles, is just sort of getting used to this and adjusting to the way that things have changed. Hopefully, obviously, when we go towards into the future, we'll return to some level of normalcy. But what I will say, I've actually worked with a lot of U1s, and what I will say is that they are, despite everything here, the ones that I've met are so energetic, so interested in being involved. So I think it will hopefully, when we get back to being in person, be something that's really exciting for you to meet a lot of them.
Yeah, I'm looking forward to it, just to put a face to a name, literally.
Face to the text box that pops up.
Yeah.
But
so, and I will say thank you to all those students who did turn on their camera. I know not everybody can, and it's not your fault that you can't. But it does, on the teaching side, help us because we can sort of gauge the reaction of what we're saying. So
definitely. All right. So that'll do it for today. Again, thank you so much.
All right, no problem, Gregory.
Thanks for listening. Check out the Chess Facebook page to know when the next episode comes out. Until then, like and subscribe to our YouTube. Bye.